Hi, welcome to this video. In this video I'm going to explain the functionality of the JAL RDA5807M library for the PIC microcontroller, which is programmed with the JAL programming language. So what will be the contents of this video? First, a short introduction of this single chip broadcast FM radio tuner device. Then I will tell something about the functions provided by the JAL library, separated into main functions and extra functions. Before continuing, I will first explain something about FM bands and FM channels. Then I will explain how you can find an FM radio station. I will show the hardware that has been used for this video. There will be a live demonstration of the device, and at the end of the presentation you can find some references. So this RDA5807M single chip broadcast FM radio tuner is controlled via an I2C interface. And the output of the device can directly be connected to a headphone, but you can also connect it to an audio amplifier, which is done in this video. And this video will show the main features of this JAL library, and I'm using a PIC microcontroller, and also the hardware that is used will be demonstrated. So what are the main functions of this library? So what it does, it translates function calls into I2C commands that the device will understand. And these are the main features provided by the library. First, the library will initialize the device. You can set the channel band, which is different for each country. You can tune to a given channel frequency. You can set the output volume, which you can mute or unmute. And you can seek to a next or previous channel. The library also provides functions to indicate that the seek was completed, or that the channel is a really FM channel, or if the channel is stereo or mono. But as said, the device is controlled via an I2C interface. So the user which is using this library has to include the JAL I2C library in the main program. There are some extra features that you can use. You can enable and disable the power of the device. There is a bus boost functionality that you can use. You can enable and disable soft mute, and the device is capable of receiving RDS information. You can set the output to stereo or mono, and you can change the channel spacing and channel de-emphasis, which is depending on the country where you live in. Of course, you can set the channel. You can get the channel frequency to which the device is tuned, and you can get the signal strength. And when an RDS signal is available, you can get some basic RDS data. So something about FM bands and FM channels. So depending on your country, there is a certain FM band with a certain frequency range. And this FM band is divided into channels. And a channel is separated by a certain bandwidth, is separated by a certain frequency. And on each of these channels you can have a radio station. So how do you now find an FM radio station? You can give the device an instruction to seek to the next channel. But as I showed before, there doesn't have to be a valid FM radio station on this channel. So the main program has to find the next valid radio station. And a way to do that is as follows. You give a seek command to the device to seek to the next channel. You wait until the seek is completed, and then you check if the found channel is an FM channel. There is a library function to indicate that. And if the channel is not an FM channel, you just repeat step 1 until you have found a radio station. When the end of a band is reached, the device will start again at the beginning of the band. So the hardware that I used is, as I mentioned before, done by a PIC microcontroller. And it's connected to a PC via a serial interface. It operates at 5 volts. The RDA5807M operates at 3 or 3.3 volts, so you need a voltage regulator to provide the right power supply. As I mentioned before, the communication is done via I2C, and since the devices are at different voltage levels, we need a level shifter. And the output of the device is connected to an audio amplifier. And for this demo, I have combined the two signals, stereo signals, to one mono signal. Then something about the pinning. It's a very small device. So on the top left you see the two I2C pins. On the top right you can connect an antenna. And on the right side are the left out and right out signals. And of course you need VCC and ground. So I have used the following hardware schematic diagram for this demonstration. We have a PIC microcontroller which is connected to the serial port of a PC using a MAX 232. We have a voltage regulator which makes the 3.3 volts for the FM radio tuner. We have the FM radio tuner itself, and since the I2C operates at different levels, we use a level shifter. And the audio is connected to an audio amplifier. In the demonstration you will see the following. First we start by initializing the module, and the main program, the sample program that I'm using, also initializes the I2C interface. Then we ask the RDA5807M to tune to a given frequency, and the information about this frequency will be shown on the serial interface. Then we start the tuning cycle in the FM band. So we start at the beginning of the band, and while tuning the output is muted. And when a radio channel is received, the information will be shown on the serial interface. And when the channel is stereo, a LED will be turned on. And if there's any other information like RDS info, we'll also show it on the serial interface. You will hardly hear the audio because it's recorded with a different microphone, but I assume you get the picture. If you want to know more about JAL, you can visit our JAL website. If you have questions on how to use JAL, there is a very good JAL lib tutorial available that you can download. If you have additional questions, you can visit the JAL's Google group and you can post your question. If there are bugs in libraries, or if you have, let's say, other specific requests, you can visit the JAL lib Google group. And all the sources, this library and sample programs, can be found on GitHub, but they are also in the JAL lib release on the JAL lib website. I hope you liked this video, and thanks for watching.